I want to take a moment to look at some potentially challenging functions with prime numbers. So go ahead and open up a new Colab notebook, colab.research.google.com. Click on that new notebook link. Let's title this primes. Now, I'm going to make sure that you understand what primes are. So prime numbers are numbers that are in fact divisible by, well, only divisible by itself in 1, right? So 4 is not prime because 2 divides into 4, whereas 5 is prime because only 1 and 5 go into 5. Okay, so first function we're going to do is it prime? Write function to determine if number is prime. Okay, so how are we going to do that? Now, when you're writing challenging functions, you have to think about how you would do it. Like let's pick a number that maybe we're not sure about, right? Like for instance, let's just think about this for a minute, okay? So I'm going to do a little text cell here. And like, let's say what is, I don't know, 173 prime. I honestly don't know. So now the thing is, how do we check it? And on top of that, how do we write a program to check it? Well, let me tell you a strategy I would employ here. Okay, does 2 divide into it? Well, no, right? If it was 174, we'd say yes, it's not prime. Next, does 3 divide into it? Now, this is a little bit interesting because the trick for 3 is that you would basically add 1 plus 7 is 8 plus 3 is 11. 3 does not divide into 11, so 3 does not divide into it, no. But we actually want to use code to do this, not like little math tricks, even though I personally find them fun. So what is that in terms of code? Do you remember the operator? 173 mod 2. We're going to check to see, is it equal to 0? That's what we're checking. 173 mod 3. Is it equal to 0? Now, let's just try to do the function first, and then we can look at ways to do it a little better. So, oh, by the way, note that like the way it looks on the left and the right, how this is different here. If you want to get it to print out better, you can just press return again. See, and then it looks better on the right side. So what this is doing here, it's like doing some kind of pseudocode. And by pseudocode, it's like not really code, but it's setting us up to write the code. And so it seems clear that, oh, if we check all the numbers, right, if none of the numbers less than 173 divide into 173, then clearly it must be prime. So we can start with that. We don't have to check all the way up to 173, but let's do that first, okay? So write the function with me. DEF is prime. That's a question, is it prime? The input's going to be some number. And then what should we be doing here? Well, how about let's just try them all. For I in range, we go ahead and start with 2. We don't want to start with 1 because that's always going to work. And let's just go all the way up to what? You can put number here because it's not going to include number. Okay. And then we simply want to check, well, what is the number mod I? Do you see that? This is where the pseudocode is helpful because I look down at the pseudocode and I see I've got 173 mod 2. Well, that's number mod I in the code because I is going to be 2 and then 3, whereas the number is like whatever we're starting with to check, 173. So what we want to do is check to see if this is equivalent to 0. Now, what do we do if it is? Okay. Well, let's figure it out. If the number mod I is equivalent to 0, then we basically want to be done with it. And we can say return, okay, we're going to return it, that, I guess it should be a string. No, it is not prime. Why no? Because, hey, if it divides equal, like take 174, You check. Is 174 mod 2 0? Yes. Therefore, the number is not prime, okay? Because it has a divisor. Okay. Now, if that's not the case, we just want to keep going, okay? This is very important with placement. Okay, this makes this a really nice advanced function. We just want to do this for all the numbers, okay? We just want to keep going, right? Check 2, check 3. If doesn't work, just go to the next one, check 3, check 4. So that's its own clause. We want to use up all the numbers. And if we do not return no, okay, when you return it, the function's over. Then you go to the next level. Where's the level? Not there, that's inside the if. Not there, that's inside the for because it lines up with the if. I'm doing the backspace, okay, which is delete on this keyboard. Do delete again, it's there. Okay, that's after the for loop. It is not inside of the for loop. Everything indented is inside of the for loop. So in that case, you can return yes. Now, I think this should work. Let's check it with some numbers that we know first. Okay. Let's go ahead and finish it out. Press Shift Enter. Let's see if the code works. Seems okay. Let's get a coding cell in there. And I'll check is 6 prime. Well, we know it should be no, right? Because 2 and 3 go into it. Good. Okay. Let's check one that we know is prime. 13. Yes. I'm looking good. Okay, let's check some bigger numbers. How about 139? I'm not even sure, honestly. It says yes. How about 174? 4. No, and let's check what I wanted to check originally, 173. And we get a yes. So it seems to be working, okay? That's actually pretty good. So what do you have an idea how to improve it, okay? When we're trying to make the best it's one thing to write code that works. It's another thing to write code that's more efficient. And we can actually make this more efficient, okay? Like, do you really need to check, does 172 divide into 173? Well, look, let's say for the sake of argument that 2 does divide into, let's just take the example of 174. Let's do 200, okay? Consider 200. When you check 2 times 100 is 200, okay, and it stops. But better yet, let's check 199, okay? You check 2. Well, 2 times 100 is too big, okay? And then you check 3. My point is this. When you're checking 3, that biggest number, 100, it's got to be less than that. Like, the reason why you don't have to check 172 is because it has to be 172 times a number that's less than that, okay? So you don't actually have to go beyond the halfway point, okay? Because if you're at the halfway point, well, again, like consider the example of 200. Okay, so better yet, 201, which we don't know. Okay, so we're checking 201. Well, once you get to 101, times 2 is too big. It's 202. But you can't check anything less than that, so everything's out. Okay? And maybe I'm not describing it too well, but my point is this. You don't need to go all the way to number. You can actually stop at number divided by 2. Okay? Let's check it. Let's see. That's like twice as fast because you're checking half the numbers, right? So in this case, there is 173 prime. Oh, because it gets a float. See, get a little error here. So we need to convert this to an integer, right? Because isn't that interesting, right? Even though it's an okay number, well, range needs it to be a float, and that can be an issue because with it rounding down, I think we just want to round it maybe up to be safe. And the global function round should do that. Okay, try it again. Shift Enter. And we get the expected yes. By the way, I was a little curious. Is 201 prime? Do you guys know? No, because 3, if you go to 2 plus 1 is 3, and 3 divides into 3, so 3 will divide into 201. Let's just play a little fun. 202 we know. What about 203? I don't know. No. Now, too bad this doesn't actually give us the divisor. And again, this is where you could actually make the functions a little more interesting, right? Like, aren't you, like, I'm curious. I'm like, yeah, but what goes into it? Well, hey, it's whatever this I is right before the return. We could deliver that. We're going to add a named parameter. And by default, we're going to have it as true. So include divisor equals true. That is a named parameter. Okay, what that means is we're giving someone the option to have that on or off. Okay, and by default here it's going to be on. So if it's on, we're going to include it here in the if. Okay, so how to do that? You need two different returns. Okay, one case, if include divisor, you're going to return both no. Well, how about an F string? F string no. And then we give the number. I divides into it. Okay. Else, just return no. Why else here? Because, you know, if include divisor is false, then this is the other case. The regular one, you just get no. Okay, so let's try it. Press shift enter. Is 203 prime. No, 7 divides into it. Isn't that cool? And again, you could take it another step further, right? Let's do one more step. Instead of just having 7 times what? Can you get it? What's the number? We got to figure it out, right? So the mod gives you the remainder, not the divisor. Well, we can get it, right? You just divide. So what is it called the dividend? I forget which is which. Well, there's two numbers. Dividend equals, I should know my math terminology. Dividend equals, what is it? It's the number divided by I. Now, that should be an integer, but remember that that'll give us a float, so we can convert it into an int. Oops. And then we can also say not just I, we can say I. And then you got to put the string out, you got to put the times out here. I times dividend. That's not divides into it. Would be say equals the number. Now that's where F strings are super useful, I think. Because that's easy in an F string. It's going to be hard in other ways. And we don't need the spaces. Okay. I'm liking this one. Let's press shift enter. Did we get it? Beautiful. I mean, that's beautiful. You know? Because when you start coding like this, you are doing what I would call advanced functions, because it's not simply about yes, no. It's like you're giving more info. That's a good function, right? You're providing more information. You're adding something, you know, and using a lot of different tools to actually do it. Okay? So I'll pause here, and if you're still interested in primes, I'm going to do one more.